Hi everyone, thanks so much for listening in. I'm going to be giving a high-level demonstration of the core APM components of AppDynamics. I'll do this by walking through how you might troubleshoot an application. So let's get stuck in.
This is the web UI for what we call the controller. This is the central platform that all of our agents are sending their data into. What you can see on the screen at the moment is a summary of all of the applications that are currently being monitored by AppDynamics. It provides us a quick, high-level view of the health of each of our applications. And most importantly, we can see the health from an end user's perspective, which allows operations team to know exactly where to focus their attention. In this particular example, you can see that the movie tickets online and the e-commerce applications may currently be impacting end users. So let's take a look and see if we can troubleshoot why that is. You can see a real-time view of our application architecture. This in AppDynamics is called the flow map. One of the great things about the flow map is that it's generated completely automatically, so out of the box, no configuration is needed to be able to start seeing this picture. And in the very dynamic environments that our applications are running in today, nodes can spin up and down, we can very easily connect to new services, and so this type of flow map enables us to very quickly and easily keep track in real time of what our application architecture looks like. Each of these nodes have a Java agent installed. We can see we've got 3 Java agents and 1 for the web server. The agents are really easy to install and require no code changes. So once the agents are installed, they'll start collecting information enabling us to form this map. And in most environments we can start to see this map forming within just a few minutes, so very, very quick time to value. And as I said, we've got the 4 agents installed here, but the rest of the services on this map have been automatically generated based on the traffic that's flowing through our agent. So we can see here that it's automatically detected a call out to a web server here, connections to databases, and also to message queues. We saw from the homepage that this particular application was experiencing performance problems. And AppDynamics knows that this is the case because it has learned and therefore understands what normal behaviour looks like for this particular application. This is done through what we call a baseline. Out of the box, we provide daily, weekly and monthly baselines. This is really useful when you have expected peaks. So in this particular example, an e-commerce site is more likely to be busy, say for example in the evening when people are doing their online shopping compared to early hours of the morning. So when we want to understand what normal looks like, we want to compare the same time. We want to compare Monday night to the previous Monday night, for example. Or in a monthly trend, we may be running reports always at the end of the month, so our traffic needs to understand what normal looks like at the end of the month. We can detect when there might be a problem. And this is done by every single transaction being monitored, and in the event of that transaction deviating from normal, we can then notice that and take action on it. So in this particular example, we can see here that the baseline is 2 milliseconds. And if a transaction were to deviate past that, then it will be marked as either slow, very slow, or errored. And then we can take action on that. So there's 2 really important benefits to this baseline. The first thing is that there's now no requirement to manage static thresholds. Every application is going to be different, so managing static thresholds can be very tiresome and actually often lead to things like alert storms and often then missing out on when their real problems do occur. And the second benefit is that when a transaction does deviate from normal, we're then proactively being able to detect that there's a problem, and AppDynamics will then automatically go ahead and capture what we call a snapshot, which is a deep code analysis of that particular transaction and enabling us to go ahead and analyse what might have caused that problem. Let's now go and take a look at those transactions. Here, when it loads, we can see all of the transactions that took place, including those that were normal, those that were classified as slow, and then very slow. You can also see there the trend of the response time, and actually you can see a peak here where as the response time went much higher, the number of transactions also dipped. Now in reality we don't really care about those users that had a normal experience, so if we remove those, we can now see a trend of the problematic transactions. Then if I want to, I can highlight the specific time that I'm interested in to find some more summary statistics. So if I move across here now, I can see that. And here you can see the concept of the transaction scorecard. So just to recap, every single transaction is monitored, and then it is either classified as normal, and then as it deviates from normal, it would then be classified as slow, very slow, stalled, or errored. So scorecard is our tool to keep the overhead very low. The balance point is about the amount of data that we are collecting and the overhead that this then incurs on the servers. And at AppDynamics, we found the perfect balance points. So we only go ahead and collect that deep diagnostic snapshot when the transaction deviates from normal. So let's now go and take a look at those snapshots. One of the things that you might notice here is this concept of a business transaction. Actually, if we go and take a look at the business transactions, these are detected out of the box automatically. And a business transaction maps directly with how an end user is interacting with our system. This particular example, e-commerce, is things like logging in, searching, adding to cart, checking out. So if a user has a problem, when they call the help desk, they're going to talk about the fact that they can't search for something or they can't add it to their checkout. They're never going to say there's a problem with the message queue or a problem with the database. So it really helps bridge the gap between the language when you're interacting with users and then trying to troubleshoot a problem. Now in this particular example, we can very easily see that there's two business transactions here where users might be impacted, and actually checkout is a pretty important business transaction in an e-commerce site. So if we drill into that, we can then go ahead and try and look for the problems at this particular transaction level. The first thing you can see here is the flow map, just like what we saw before, but this time the components shown here are just those that are specific to this particular business transaction, just those that are specific to the checkout. What this really means, one of the great benefits of this actually, is that in the event of there being a problem, most of my customers talk about the concept of running a war room when they're trying to debug a problem. Traditionally, it would have meant bringing everybody into a room, everybody trying to prove that it's not their fault. And with a tool like this, we can automatically bring down the number of people that we're going to bring into our war room. We can immediately see here which SMEs we need to bring together to start trying to solve that problem. If I want to troubleshoot where the performance problem might be, the best thing for me to do is to go ahead and take a look at those snapshots that were captured of the transactions that were classified as very slow. And actually I had 49 out of 409 transactions that were slow. So if I drill into here, I can then go ahead and select one of these transactions to take a look at. Now, as you can see here, this is an actual transaction that took place. There's no requirement to try and recreate a problem that was reported to you. You can see the actual transaction that took place here. We can see that this particular user was using Internet Explorer 9, and I can see from end to end the call that took place. Now, AppDynamics highlights what it believes the potential issues might be. You can see that here on the left-hand side, and if I wanted to, I could just drill straight into here. For me personally, I like to have a look at this flow map. It's quite easy to have a quick view of where the problem might be, and even if you're not familiar with the application architecture, it's very intuitive and very easy to read. And you can see here that this was 50 seconds. Wow, that's quite significant, isn't it? And if you look at the timings of all of the interactions, the thing that stands out the most, and in fact you've got a big warning sign here, is that 49 of those seconds were actually communicating to the database. So I can immediately tell that actually the problem is likely to be this particular call here. Now, if I wanted to, I could drill down and start from the e-commerce service, and I can see end to end the transaction that took place. I mean, here, to me, I think it's quite obvious that the problem is with this connection. So I'm going to drill down here and take a look at it. I'm going to sort, these are the threads that took place, and I'm going to sort by the exec time and just drill into one of these calls. And here, I can immediately see that most of my time, in fact 99% of my time, was to this JDBC. So if I click here, I can then see instantly the particular query that took that time, and just over 8 seconds to run this query. So if I wanted to now, I've believed that I've found the SQL statement that's caused the problem, I can just grab a link to this particular view, and I can pop that link over in a trouble ticket, maybe a Slack message to the DBA and say, I think there's a problem with this particular SQL statement. Could you please go ahead and take a look? I could just stop here. I believe I found what has caused the problem, that particular SQL statement. But actually, I could also maybe try and find out why that SQL statement is slow. And that's actually one of the great things about AppDynamics. We actually provide end-to-end visibility. And if I want to, I can now go and have a look into the database itself. If I right-click here and view in databases, I can see a list of all of the queries running against this particular database. Now the second one down is the one that was highlighted as taking 8 seconds to run. And here we can quite quickly see that actually most of the time consumed on the database is the one above. And so from a like an operational perspective, I wouldn't normally have visibility to this type of thing. It would normally just go to the DBA and they'd have to search it. Whereas this type of visibility helps me see that actually probably the main reason why this has taken a long time is because there's somebody else running a query. Maybe they've logged in and just stuck a query in randomly, and actually that is causing contention, meaning that my query is a bit slower. Now, one of the great benefits of this is that as an operational member of staff, or even maybe as part of the development team, I'm very easily able to detect what might be causing that slowdown myself before approaching the DBA team. A lot of companies that I've worked with in the past have had a much lower number of DBAs to operations and development staff. Their time is very valuable, so if I'm able to detect what might be causing the problem before approaching the DBA, it's going to add a lot of value. The DBAs are going to be happy, and the operations and development staff are going to have a lot more insight into what might be causing the problem. So now if I wanted to, I can actually go and take a deeper dive into any one of these queries. I mean, in our particular situation, we can quite easily tell that the reason why our query is slow is because there's another query that's taking up all of the resources. But if I wanted to know why that query is slow, I can actually just drill into here and I can see all the information about the actual query itself. I can also even go and view the execution plan if that's something I want to do as well. And once this is generated, I can then see some specific details about this query, and immediately I can see that there's a Cartesian join happening here, and look at the cost of that. So it's obviously a poorly written query, probably by somebody that's just quickly hacked up a query and just ran against it. But the important thing to note here is that as a developer or as an operations member of staff, I'm able to get this level of insight myself.
So if you're still here, thank you very much for listening. I hope you found the demo useful. I thought I'd finish by just doing a very quick summary of the key things that we talked about in the demo. So the first thing was the application flow map. This is generated completely out of the box with no configuration needed. We then talked about the concept of a dynamic baseline. This is what enables AppDynamics to run with a very low overhead in production. Every single transaction is monitored, and then in the event of that transaction deviating from what normal looks like, we'll go ahead and we'll create a deep diagnostic snapshot, which can then be used to troubleshoot where the performance problem is. We also talked about business transactions. These directly relate to how a user is interacting with our system. These are detected out of the box, and at a high level we can very quickly see which transactions may be impacting users. And then finally, I showed you with just a few clicks how you can troubleshoot a performance problem. So thank you very much for listening. Again, I hope you found it useful and hopefully see you again soon. Thank you.